the Aircraft Certification Channel. I'm Rafaela Caillaux, and today we are here to talk about my favorite subject, aircraft certification. But to do that, I brought a guest, Ansel James, who is here with us again. So Ansel was here before talking about particular risk analysis and other things, and there will be a link in your screen in case you want to see his video. First of all, Ansel, thanks for being here with us again.
It's my pleasure. My pleasure.
Okay, Ansel is a senior certification and safety engineer, and with a lot of experience in aviation. He has worked over 20 years for the FAA, Alaska Airlines, and Mitsubishi Aircraft Corporation, where we could work together for a while, right?
Yes.
And so if you want to know more about his professional journey, his link will be in the description area. So, Ansel, can you start explaining to us what is certification?
Certainly. So certification is what happens when an authority or a governmental authority says that, yes, something, in our case, you're talking about aircraft design, meets certain requirements and regulations, and it's safe to do. It's determined to be acceptable to be able to perform a certain function. In our case, we're talking about aircraft design, the type certification process. That is the process by which the government, the authority, regulatory authority, determines that the aircraft design meets the applicable regulations and is also in a condition for safe flight.
And why, in your opinion, why do you think aircraft certification is so important?
Aircraft certification is important because aircraft certification is an important part of the aviation safety structure. Aircraft certification, as I mentioned, is the design of the aircraft, but then you also have certification for the individual aircraft as they go out the door, as they're produced. That's the airworthiness certificate that the aircraft received, that particular aircraft is meets the requirements to be able to operate, to be able to fly in the airspace environment. We also have production certification, which is given to the manufacturer to be able to produce the aircraft, to manufacture the aircraft, and also certification, TSOs and PMAs are given to suppliers to be able to make spare parts and so on and piece parts for the aircraft. Also, we have certification of airmen. The pilots and the mechanics are certified by the regulatory authority because they've met the requirements and the criteria necessary for them to be able to operate the aircraft and maintain the aircraft within the airspace environment.
Okay, and then you also have the maintenance organizations and sometimes ATCs, airports,
yes,
and so on that composes all the aviation system, which is actually a complex system, right?
Yes.
And so when we are talking about aircraft certification, we are talking about the type certificate itself.
Yes.
And what's the relevance of the type certificate?
So the type certificate shows that the aircraft design itself has met the publicly acceptable levels of safety, the minimum publicly acceptable levels of safety described in the regulations, because that's what the regulations represent. The regulations themselves incorporate the lessons learned over the years from events from different aircraft, maybe accidents, incidents, or just testing findings that other manufacturers have found and have worked with the authorities to incorporate into the regulations so that mistakes aren't repeated and errors aren't repeated and so on. So that's very important to show that by complying with the regulations shows that the design meets those requirements and meets an acceptable level of safety. Also, using the engineer's knowledge and experience to show that there aren't any unsafe features that may not be addressed specifically in the regulations.
Yeah, so it's interesting because the system is a kind of a closed loop and feeds back to always evolve the level of safety of aviation, getting the inputs from all the accidents and incidents, and raise the level of safety of the system. Right?
Yes, and it's important because it's important to know that it's publicly accepted because the public has the opportunity to provide comments and feedback, not just the general public, but also manufacturers and so on. They have the ability to contribute to the development of the regulations through their use of the comments comment period. They can comment on the regulations, new regulations or significant guidance that may come out from the authorities. They're able to provide comments to the authorities before those regulations become effective, so that the authorities can use that opportunity to incorporate different elements of those comments to make the regulations more practical, more feasible for the manufacturers to be able to comply with.
So in fact, the authorities have like a collaborative rulemaking process where society can directly input in the regulation itself, right?
Yes.
And there is, all the major authorities has a specific link that will leave in the description that you can make your own comments and follow what's being changed in the regulation right now. We talk about how the requirements evolve with time and with accidents in another video, and I'll let the link also in the screen so you can see live that we did about the Boeing 727 flight 227, an accident that happened in Salt Lake City, and if you want to know more, you need to access the link. Getting back to our conversation here, I would like to talk about the time. Actually, traditionally, we have like by regulation, a time frame of 3 years for general aviation, like Part 23 and Part 27 aircraft. And for transport category aircraft, we have 5 years as a regulatory time to get a type certificate. But we know that most of the OEMs do not complete their development and certification process in this time frame. What's your opinion on that, and what are the main aspects that impacts the development time?
Yes, you're absolutely right. So there is a time period, a set time period between when the applicant makes his application and then they discuss a certification basis with the authorities, and that sets the specific regulations that they will comply with over the development and certification period. So if they go over that set period of time, then the certification basis may change, and that may involve incorporating new or different regulations into their certification basis that they will have to comply with. And to be able to do that, they may have to change different aspects of their design of the aircraft to be able to meet those new requirements.
And this can even impact even further the time and schedule, right?
Schedule, yes, exactly.
Because you need now to incorporate requirements that you didn't have in the beginning of the process.
Yes. So throughout the course of the aircraft development, you have the requirements that you as a manufacturer set out for yourself, what you want the aircraft to do, and then you want to make sure those requirements are clear and that you can test to them. Then you take those requirements and you send it off to your suppliers, your component suppliers, and your different design teams who would design the architecture and the subsystems and so on. So if any changes in the regulatory requirements may change the safety requirements, may change your architecture, which extends your development time. You want to be able to understand those the changes that may come, that you understand that there will be changes as you learn things through your testing, through your development, your analysis, and your testing, and you may have to go back and make changes. And that's an iterative process by which you learn more about your aircraft, and the design becomes more and more mature, and you get closer to what you actually want. So you want to be able to minimize that to the greatest extent practical, to help reduce that certification time, while still obviously ending up with the best aircraft that you can. You want to be able to make sure that your suppliers have the correct requirements. You want to make sure that you're able to incorporate those into your design. You want to make sure that as you go forward with the testing, if you have opportunities to combine some of that development testing with the certification testing, that you're able to take advantage of that. More experienced OEMs or manufacturers are able to do that because they've been there before, so they know what testing they're able to combine. They're more experienced manufacturers also have more data from previous testing.
Sure.
And they're able to work with the authorities so that they can agree on what data from their previous testing they can incorporate into their current testing to, again, reduce the amount of testing that they do for this particular aircraft, to determine what tests are applicable and so on, that they can combine and use to their advantage. Newer manufacturers don't have that ability, that luxury for having that additional data. They'll have to generate it, so that takes time.
Okay.
So if you're able to do what you can to shorten that time frame, also by understanding the type of testing that you'll be doing, understanding the risks of the testing, having maybe more prototypes with slightly different configurations to test different things, so that a design change in one or failure of a test in one doesn't impact other ongoing testing. That will also help shorten your development and certification timing.
Okay, so actually you want to shorten your development time also because that's directly impacting the cost of the development.
Yes.
And so putting kind of prototypes, instead of working with one prototype, more than one prototype at the same time, you would run things in parallel.
Yes.
And being able to have more margin for managing the changes and things, right?
Yes, you're able to manage the critical path.
Okay.
For the testing. You're able to understand exactly where it is and account for it and put mitigations in place.
Okay, and what would be, in your opinion, the main opportunities for applicants to manage time and cost?
The main opportunities, I believe, would start with the conversations with the authorities. Make sure that as early on in the development phase, that you communicate often with the authorities, so that when you make your assumptions for things like pilot reaction time, different characteristics of the aircraft behavior during certain phases of flight, when you make those assumptions, you're able to harmonize with the authorities, be able to communicate with them and be on the same levels, so that they understand and accept those assumptions that you're using when you do your analysis and you develop your testing protocols and so on, so you go forward. So once that's done, you're able to be able to better reach acceptance with the authorities on things like pass-fail criteria. You pass a test and you want to make sure that you're able to take credit for the test you pass, depending on the aircraft configuration, because in some cases in most cases the test aircraft isn't going to represent the final aircraft. So you want to be able to say that for these aspects of the test, the configuration of the specific these areas of the configuration of the aircraft are applicable, maybe not these other areas. So you want to have that conversation early and often with the authorities so they understand what you're doing and they can accept your test results as proper verification of your design and how you will meet the requirements.
Okay, so basically it's early involvement of the authorities and spending time to communicate well and also to plan ahead.
Yes.
What you intend to do, so you can kind of go through the development path more smoothly.
Yes, and also to be able to manage the changes.
Okay.
You'll come across changes. You'll find things as you learn about your aircraft and you learn about the design and the architecture and how things work together. You'll make changes, and it's their ability to manage those changes, to effectively manage the changes and minimize the risks. And in some cases, to be able to see ahead of the game, to be able to predict where there can be some failures or some things that they may not know. Once they know as a OEM, as a manufacturer, you know what you know and you know what you don't know. And as you go and find it out through testing, you're able to incorporate that information into your long-term planning.
Okay.
So that you're more able to mitigate risks that will come, risks to the schedule, so that you can better you can save money and stay within schedule.
Okay, so planning for the known and also planning for the unknown is important.
Yes.
Okay, so thank you very much for being here with us again.
That's my pleasure.
It was really nice to have this opportunity to share knowledge with you and to get some from your experience.
Oh, thank you. It's my pleasure to share.
Okay, so if you want to contact Ansel directly, his link will be in the description area. Thanks for watching and enjoy your journey.